Good afternoon, guys. Welcome to Videos Online Tutorial. Thanks for watching our videos online. Please do not subscribe. Please do press the subscribe button and notification bell. That's our updates on this YouTube channel. Thank you and God bless you. Today, I'm going to be considering what physics alternative to practical in preparation towards YGCE 2022. And here is the questions on electricity, the practical aspect of electricity, which is an alternative to what? To practical. Here we'll be given what? We are given what? In the diagram, OS is a potentiometer. In a real life experiment, this is potentiometer, and we are told that what? OS is a uniform potentiometer wire of 0 to what? 100 centimeters. So it is indicated by what? OS here on the circuit diagram. And we are given that what? E0 is the accumulator of the what? Of the circuit. E1 is a what? Is a cell, which is a single battery. Is a cell. A single battery is for cell in this what? Circuit. And R is a what? Is a resistance box. R is a resistance box. J is the jockey. And G is the what? Is the galvanometer. And these are all given in an alternative to practical. And this practical has been carried out in the what? In the lab. And here you don't need to know the what? The apparatus used in this experiment. All you need to do is what? Use this information and get your what? Answers to the question given to you in the exams. So I'm just giving you the what these things represent as far as this diagram is concerned. So now R is a resistance box, J is the jockey, and G is a central zero galvanometer. Now we are not told that with a K1 closed, that is, this is the K1. That's why they name it what? K1. K1. Now when the K1 is closed, and while the K2 is open, when you bring this connection together, it means it is closed. And this one is left like this. We are told that a non-deflection is obtained at P0 on OS. A non-deflection, that is a non-deflection galvanometer is measured, and that measurement has P0 on OS. Now, as this was closed and this one is open, there is a measurement taken from what? As P0 to determine the what? The length of the what? Of the potentiometer wire when K1 was open and K2 is closed. So P0 was determined then. Now, this value of OP0 is measured and recorded. It was measured and recorded. And what else again? We are now told that K2 is then closed. Then this K2 was closed, and the resistance box is set at a known resistance R. Now, the resistance box was what? Was set to a known resistance value of R. Now let me show you something here. These are what it means to what? To have a resistance what? A resistance box. And we are told that this resistance box was set to a known value of what? Of R. Now let's continue. The point of non-deflection P on OS is obtained and OP is measured and recorded. K2 is then opened. The experiment is repeated for more increasing values of R. In each case, OP is measured and recorded. Figure 3a and figure 3b illustrate the resistance Ri and corresponding Li, OPi respectively, where I is 1, 2, 3, 4, and what? 5. Now, we are told that what? The figure obtained for this value for the experiment is what? Is summarized in figure 3a and 3b. Now, this experiment value was obtained from this circuit diagram was given as figure 3a and 3b, meaning that we are going to use figure 3a here and 3b here to obtain our resistance value and our readings on potentiometer. Now, and we are not told that notes for figure what? 3a, which represents the what? The resistance box. We are told that unshaded circle indicate the plugs are being removed. Now, on this resistance box, that's why I want to show you the resistance box. This resistance box now, when you remove what? The unshaded circle indicate that the plugs have been removed. Now, this unshaded circle here, which is 2 ohms here, it means that it has been unplugged from the resistor box. So it means that if they want to do it maybe practical, this 2 ohm will be unplugged. So it means 2 ohm resistor is used for R1. So that's what it means. So they just use this diagram to represent it instead of giving us the real resistor box, because this is an alternative to what? To practical. Now, so why the potentiometer wire is given, the potentiometer length of the wire is what? Is given in form of a straight line, and we are told that what? Please be mindful of this straight line very well. I believe you can see it. From here to here is 20 centimeter, and we are told that this is our P0, these are P1, P2, P3, P4, and P5. Now, we are now asked to use this diagram figure 3A and 3B to answer the question that follows. Now, read and record what? Ri. We are asked to read and record what? Ri. Now, the first thing is to draw the table of value for this experiment. So, if I have serial number now, I have my serial number. That's the first thing to do. Serial number. Now the first thing we are asked to do now is Ri, which is the resistance measured in what? In ohm, and we have been given in form of what? In form of figure, which is in box, and the shaded one means that what? The 2 ohm resistor is unplugged here. So meaning that for this first reading here, we have what? 2 ohm resistor to be what? Unplugged. Here for the second one, we have 2, 3, 4, 5, then what? 5. We have 5 readings there. So let's just demarcate this so as not to mix everything up. So now we have what? The first one is 2 ohm because it's only 2 ohm that is unshaded here. This one is 1 and 3. We're making what? 4 ohm resistor. This one is what? 6 ohm, making what? This is unshaded 6 ohm resistor was unplugged here. This one is what? 3 and 5. That is 8 ohm resistor was unplugged here. And this one is what? 4 and what? 6. Meaning that this 10 ohm resistor was what? Unplugged here. Now we are not told, I will measure the Ri now. Measure and record the raw length of OPI. Now the raw length of OPI is the distance between this point and this point to P1, to P2, to P3, to P4. That's the raw length. So you call the raw length Li, which is measured in what? In centimeter. We are told it's in centimeter. It's 20 centimeter. So the unit to be 20 centimeter. That's the raw length. Now, you are now going to use your what? Ruler. You take your ruler and then you place it on this measurement. This might not be accurate because I'm using the board directly. But if you check this one, this is around 3 points. First one is 3.55. First one is 3.55. P1 is 3.55. P2, I haven't measured it before. P1 is 3.55. The P2 is 3.75. So this is 3.55 centimeter. This one is 3.75 centimeter. When you consider to measure this one will give us what? 4.5 centimeter. This one is 5.0 centimeter, and this one is 5.30 centimeter. So that's how we get the raw length of what? Of why the P0 is 9.0. P0 is what? 9.0 centimeter. So you can as well write it somewhere here so that you will not mix it together. Let me first close this place now. P0 is 9.0 centimeter. Now that's the raw length of what? Of OPI. So it is measured directly from this, and then we are now told to use the given scale to convert OPI to real length XI. Now we have to use this scale to convert this OPI to what? To real length. So which is SI. XI now will be equal to what? Will be equal to that. Say 1 centimeter represents 5 centimeters. So every 1 centimeter that you measure on this is what? Is 5 centimeter. Please know that 1 centimeter represents, the scale given to us is 1 centimeter represents 5 centimeter. So if I now measure 3.5 as my raw length now, 3.5 centimeter. So using the scale now, it will now be 3.55 multiplied by 3.55 multiplied by 5. So that will be my what? That will be my what? New SI. That's my new SI. So it's going to be in centimeter as well. So let's close this now. It's going to be in centimeter. So 3.55 times 5. 3.55 times 5. You take your calculator, then you do your calculations. So 3.55 multiplied by 5. We have 17.75. 17.75. So 3.75 multiplied by 5 again, 18.75. I hope you are following. 4.45 times 5. We are having 22.50. Then 5 times 5 is 25.0. Why? 5.30 times 5. We give you 26.50. So with that now, we have successfully calculated down aspect. Now what are the next thing we have to do again? So we are asked to what? Evaluate SI. SI inverse. This SI, you have to evaluate S inverse, which is what? S inverse means 1 over x. S inverse is 1 over x, which is what? Is in per centimeter. 1 over x. So 1 divided by this now is what we are going to do now. 1, press your calculator, 1 divided by 17.75. So we have 0.056 to 3 decimal place. We have 1 divided by 18.75. We have 0.053. That is the next one. So we have 1 divided by 4.5. We have 0.0. Have 1 divided by what? 1 divided by 4. Sorry, we are using this one, 18. So we have 0.53 here. So we are going to use 1 divided by what? 1 divided by 122.1. 1 divided by 22.50 is 0.044. Then 1 divided by 25, 0.040. The last one is 1 divided by 26.50. Have 0.037. So now 0.037. So that's that to 3 decimal place. Now with this now, we have successfully gotten our S inverse. The next thing is what? Evaluate as well R inverse. So R inverse will be what? R inverse will be 1 over 2, which is 0.500. 1 divided by what? 4 should be 1 divided by 4 should be 0.25. 0.250. 1 divided by 6 is 0.166. 1 divided by 8, that should be what? 0.125. Then 1 divided by 10 is 0.100. So that's that about what? The table of what? Value, as you can see. That's that about the table of value. Now the next thing we have to do now is to plot our graph. Plot the graph, a graph of X inverse on the vertical axis against what? R inverse on the what? Horizontal axis, starting both axes from 0. So we have to plot this graph of this against this. So the next thing is to plot the graph of x inverse versus, write it in full, r inverse, s inverse versus what? R inverse. And the next thing you need to do here is to, for of us, write out the values you have to plot on the graph of s inverse versus what? R inverse. Now I will quickly clean this side to write it out so as to know the values we are to what we are going to plot. So quickly write this and then put it down, because I will hand my graph very soon now. So we are going to be having what? The graph of what? We have x inverse is equal to per centimeter, then r inverse we have what? Per ohm. So we have 5 column. The first one is what? You can plot this one to 3 decimal place for us to get accurate value. 56, 0.056, 0.053, 0.044, 0.040. So you can maintain that one 0.056, 0.053, 0.044, 0.040, 0.037. So with that we have 0.0. Now this one we can plot it to the 2 decimal place. 0.50, 0.25, 0.17, 0.13, 0.10. So that's that. These are the 2 values that I'm going to be plotting on the what? On the graph. These are the values. So graph of x inverse in centimeter per centimeter against r inverse ohm per ohm centimeter. So these are the what? These are the values we are going to plot on the graph. Please note that. Take note of it so that we'll be able to what? Hang our graph and then what? Plot it. So I haven't hung the graph now. So we have to plot the graph of write the title first. Graph of x inverse per centimeter against r inverse per ohms. Please take note of that. Bracket close. So the next thing is to choose your scale. Your scale, look at it, this is 0.056. I can easily use what? 0.01 on y-axis, like 2 centimeter represents 0.01. 0.01, because it's 0.05, 0.01 on x inverse axis represents 0.01 per centimeter. Please note that this one is per centimeter. The unit to do per centimeter on x inverse axis. Now we have 2 centimeter represents, the next 2 centimeter represents what? You can use 0.1 here because this is the highest is 0.5, so 0.1 per ohm on r inverse axis. So that's our scale. So please take note of that. So with that now we can easily what? Plot our what? Graph. Now let's draw the straight line here. Now we have to start from origin 0. So it's supposed to be what? 0, 0. So now this one is 0 point what? 0.1, 0.02, 0.03, 0.04. Can even add 0 to at the back. So let me add 0 to it. 0. So we are having 0.010, 0.020, 0.030, 0.050, 0.060. So now as that, make sure they have equal spacing. So this is x inverse per centimeter. Now this one is going to be what? 0.10, 0.20, 0.30, 0.40, 0.50, 0.60, and so on and so forth. So this is R inverse per whole. So having done that, now let's go into our what? Our plotting of the graph. So here we have what? We have 0.10, 0.020, and so on and so forth. Here we have 0.10, 0.20, 0.30, 0.40, 0.50, 0.60. So that's that about our scale. Now, having done that, now let's go into the plotting. We have the first one here is 0.56 against 0.5, 0.56, 0.056, 0.056. Now this is 0.051, 0.052, 53, 54, 55, 56 against 0.5. Again 0.5. This is where your 0.5 is. So this is your point here. Please take note of that. That one is 0.053 now. 0.51, 52, 53 here. Have 53 against 0.25. Very far from 0.25. 0.21, 21, 22, 23, 24, 25. Trace this up here. We have a point here, 0.53 against 0.25. Then 0.044. 0.044 is here. 0.41, 42, 43, 44 against 17. 15. This is 44 against 17. 15, 16, 17. So we have a point here. 44. Okay, 44. This one is 0.5456 against 0.25. 44 against 17. Then the next one is what? 0.13. 0.13. 0.13. 0.13. 13 is here against 13 against 4. Against 4. 13 against 4. Against 4. 13 against 4. 0.040 against 13. So 0.040 is here. 13 is here. 13 is here. You can see our words. And the last one is 0.037. 0.037. 0.037 against 1. 0.037 against 1. So this is 1 here. So that's that about our point. And now let's draw our straight line graph. So if you look at this very well, you take what? The 4 here, apart from the 5 that is kind of outliers. So 2, 4 points, while this one is a very far range. So now we have our graph now. Can we plot the slope? So you can extend this if you want to make your graph a little bit line your graph. So that's what I'm trying to. The marker is somehow, that's why it's kind of having lines like that. So that's that about that. There's a point here as well. So my marker. So we have that to be that. So now let's quickly what? Better your graph, your slope should be bigger than to be what? Smaller. So that's why I try to extend my line. So we have, let's see where we can pick here. I'll change my marker, please. So that's that about the graph. So we have the out. So now this point, trace it. Sun seems to fall in the middle. So you have to. And now you have to. So that's it, and that's sorry for the markers. So we have so this is what, don't forget this 3. Let me take another marker. So we have what? 0, 3, 0 here. So we have, look at this, is going to be 0.070. This is going to be what? 0.717273. So these are x inverse 2, which is what? 0.073. And this one is our S inverse what? 1. This is our R inverse 2, R inverse 1. We have slope is equal to changing S inverse and changing R inverse. So that is slope, the vertical over horizontal. So we have what? X equal to what? S inverse 1, S inverse 1, 2 minus S inverse 1 divided by what? R inverse 2 minus R inverse what? 1. So S is equal to, now what is your X2? Your X2 is 0.71, 7273, 0.073 minus 0.030 per centimeter divided by, this one is 0.44, 0.44 minus 0.4, 0.04. We can count it though. This is 0.01, 0.02, 0.03, 0.04. So that is per what? Per ohm. So when you minus this, what do you get? Minus this, what do you get? You have 0.073 minus 0.030. So one is equal to 0.043 divided by 0.44 minus 0.04. So when you divide this one, 0.043 divided by 0.4, X is equal to 0.1073. So S inverse 0.03 minus 0.0 give us 0.043. So then this one, so this one minus this one give us what? 0. Because this is 0.044, so 0.044 minus 0.04. So that's how we get what? And the unit here is what? Per centimeter. This one and this one goes up ohms. So that's that about this. So we have to calculate the intercept here. If you check this place, I have to what? Determine the S, the intercept C on the vertical axis, and then find K1, 1 over C, and K2 S over what? So we have to determine what? The vertical intercept. The vertical intercept is here, which is 0.0. This is 0.025. So this place is 0.026 per centimeter. So your K1 will be 1 over 0.026, and that will be what? 1 divided by 0.026. 1 divided by 0.026. That will be what? That is 38.46 centimeter. Don't forget it's per centimeter, and it's come from centimeter. So why K2? K2 is equal to S over C, according to the formula given to us, S over C. So what is your S? 0.1073 per centimeter ohms over what? 0.026 that you get for your C. So per centimeter cancel per centimeter. We have what? 0. 0.1073 divided by 0.026. This is what? 4.126 ohms, which is equal to what? 4.1 ohms. So that's that about today's class. Please, if you haven't subscribed, please do press the subscribe button and notification bell. That's all our updates on this YouTube timeline. Thank you and God bless you. Amen.